So today we're going to take a look at the cumulative review. So this first number 1 here, let's see, let f of x equals the square root of x plus 2 for x is greater than or equal to 2, and g of x equals 3x minus x when x is an element of a real. So that just means x is a real number. Write down f of 14. Okay, so that would be, it's really big there. Let's see. So that would be the square root of 14 plus 2. The square root of 16, which is 4. G of f of 14. Well, we found f of 14, so this is really g of f of 14. Well, we already calculated out that inside part. We said that's 4, so this is really g of 4, which would be 3 times 4 minus 7. So 12 minus 7 is 5. G negative 1 of x. So that negative 1 means the inverse. So we'll switch our x and y's and solve for y. So you have x plus 7 equals 3y divided by 3. So we have x plus 7 over 3 equals our inverse of g. So the second one here, the following shows a diagram of the graph of f with domain from negative 2 is less than or equal to x is less than or equal to 4. The points negative 2, 0 lie on the graph. Okay, so negative 2, 0. And the point 4, 7. Write down the range. Well, our range, our y values, so our smallest one is 0 is less than or equal to y is less than or equal to 7. Find f of 2. Well, when x is 2, y is 3. Write down the inverse of 2. So that means, here's our inverse function, has something. So that means on our regular, there's some x value where y is 2. So let's see, where is our y2? Well, right here. So our x value would be 0. So this is saying 2, 0. Yep, so that would work. So it would just be, the answer would just be 0. On the grid, sketch a graph of the inverse. Well, we have to switch our x's and y's. So negative 2, 0 becomes 0, negative 2. Let's see, we had 2, 0, 2. So that becomes 2, 0. This one was 2, 3. So it becomes 3, 2. Here's another nice point. So that's 3, 4. So that becomes 4, 3. And then 7, 4. So it becomes right there. And again, as a reminder, this is, if we were to reflect it over the line y equals x, we would have our reflection there. So let's see on this next page. The following diagram shows parts of the graph of the quadratic function of f. The vertex is 3, negative 1. So there's our vertex. And it has x-intercepts of 2 and 4. 2, 0, 4, 0. The function can be written in the following form. Write down the values of h and k. Well, that's just our vertex. So h equals 3 and k equals negative 1. The function can also be written in the form of f of x equals, so that's our factored form. Write down the values of a and b. So a equals 2, b equals 4. Find the y-intercept. Well, let's see. So we have a couple equations. So we have y equals x minus 3 squared plus 1. But we also have y equals x minus 2, x minus 4. Well, by definition of the y-intercept, all we're plugging in is where x equals 0. So 0 minus 2 times 0 minus 4, negative 2 times 4 is 8. So our y-intercept is 0, 8. We should also get the same thing if we plug in, whoops, this was minus 1. I'm sorry about that. if we plugged it into this one. So 0 minus 3 squared minus 1. 9 minus 1 is also 8. So for here, f of x equals x squared plus x minus 6. Write down the graph, the y-intercept. Okay, so 0 squared plus 0 minus 6 is negative 6. So it's the coordinate 0, negative 6. Solve when f of x equals 0. So when does 0 equal x squared plus x minus 6? Well, this is factorable. So we have x plus 3 and x minus 2. So our answers would be when x equals negative 3 and x equals positive 2. So number 5. Let f of x equals p plus 9 over x minus q when x can't equal q. The line x equals 3 is a vertical asymptote. Write down the value of q. Well, our vertical asymptotes are in the denominator, so q has to equal 3. Because then on the bottom we'd have x minus 3, so we'd say our vertical is 3. The graph has a y-intercept of 0, 4. Find the value of p. So we know it's y equals p plus 9 over x minus 3. And we know that coordinate 0, 4 is on the graph. So 4 equals p plus 9 over 0 minus 3. So 4 equals p plus 3. So p would have to equal 1. The graph has a y-intercept of 0, 4. Write down the equation of the horizontal asymptote of the graph. So now our equation is y equals 1 plus 9 over x minus 3. So our horizontal, this is shifted up 1, or you could think of it this fraction as x gets really big, x minus 3, so 9 over a really big number is 0. 0 plus 1 is 1. So our equation for our horizontal is that y equals 1. Number 6. Let f of x equals 3x minus 2 and g of x equals 5 over 3x. Find the inverse of f. Okay, so x equals 3y minus 2. So we have x plus 2 equals 3y. So we have x plus 2 over 3 equals our inverse. Show that g of our inverse of x equals 5 over x plus 2. So we have 5 over 3x, but we're going to replace our x there. So 5 over 3 times x plus 2 divided by 3. So we have 5 over x plus 2. 6c. Let h of x equals 5 over x plus 2. The graph of h has a horizontal asymptote at y equals 0. Find the y-intercept. Okay, so 5 over 0 plus 2 is 5 over 2. So our intercept is the coordinate 0, 5 over 2. Sketch a graph. So we know the asymptotes are at 0, and it would be at negative 2. And our y-intercept is 2.5. So here's our quick sketch. For the graph of the inverse, write down the x-intercept. Well, so our x-intercept, we just switch the x and y of our y-intercept, so we have 5 over 2 and 0. Because our x-intercept becomes our y-intercept. For the graph of the inverse, write down the equation of the vertical asymptote. So on our regular one, we had one at y equals 0. That's not 0. And x equals negative 2. So our inverse is going to switch. It would be x equals 0 and y equals negative 2. So our vertical one is at x equals 0. And I think this one's supposed to be a, my bad. Given that the inverse of a equals 3, find the value of a. So on our inverse, there's the coordinate of a comma 3. So that means on our regular one, it's 3 comma a. So we can go back to our original function, 5 over x plus 2. So we'd have 5 over 3 plus 2, 5 over 5. So it's going to be 1. Number 7. So we're given this equation. The line x equals 3 is a vertical asymptote. Find the value of c. I think this is supposed to be an x right here. My bad. Okay, so there's a vertical asymptote at 3. So that means our denominator has to equal 3. When we solve for x, it's got to be equal to 3. So let's see, cx equals negative 3. So in order for x to equal 3, c would have to be negative 1. Write down the equation of the horizontal. Well, if we have 8x plus 5 over negative 1x plus 6, our horizontal, the degrees are the same, so it's negative 8 over 1, or negative 8. Consider the graph of f of x equals x plus 1 over 5x minus 10 plus 3. Find the y-intercept. Okay, 0 plus 1, 5 times 0 minus 10 plus 3, 1 over negative 10 plus 3, so that'd be 2 and 9/10. Find the equation of the vertical asymptote. So verticals, we look in our denominator. So when does that equal 0? So 5x equals 10, so it's at x equals 2. This next one here, the following diagram shows a graph of f of x from negative 6 to negative 2. The points negative 6, 6 and negative 2, 6 lie in the graph. And there's a minimum at negative 4, 0, so find the range. So let's see, 0 is less than or equal to y is less than or equal to 6. Let g of x equal f of x minus 5. On the grid, graph that. So this moves to the right 5. So we can take every coordinate to the right 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Write down the domain. So now our domain are x values. So it goes from here to here. So negative 1 is less than or equal to x is less than or equal to 3.